In this video, we'll be looking at analyzing and graphing a quadratic function. Let's consider f of x equals negative 2 times x minus 1 squared plus 8. We will determine whether the graph of the parabola opens upward or downward. We'll identify the vertex, determine the X-Intercepts, in other words, solve for x, and if x is a real number, then the value is an X-Intercept. We'll determine the Y-intercept, which means we'll set x equal to 0 and solve for y, or for f of x. We'll sketch the function. We'll determine the axis of symmetry. We will determine the maximum or minimum value of f. And lastly, we will write the domain and range in interval notation. So let's get started. Looking at part A, which asks us to determine whether the graph of the parabola opens upward or downward, because our lead coefficient is negative, this parabola opens downward. Next, we'll identify the vertex. Because this parabola is of the form f of x equals a times x minus h squared plus k, where the vertex is given by hk, our vertex is 1, 8. To find our x-intercepts, we'll let f of x equal 0 and solve for x. First, we'll subtract 8 on both sides. Then, we'll divide negative 2 on both sides. Next, we'll apply the square root property, which means we take the square root of both sides and put a plus or minus in front of the square root of the constant. This gives us plus or minus 2 equals x minus 1, which can be written as two separate equations. 2 equals x minus 1, and negative 2 equals x minus 1. Solving each for x, we get x equals 3 and x equals negative 1. Therefore, our x-intercepts, or the points where the graph crosses the x-axis, are at negative 1, 0 and 3, 0. To find the y-intercept, we let x equal 0 and solve for y. So we have f of x equals negative 2 times 0 minus 1 squared plus 8. That becomes negative 2 times 1 plus 8, which equals 6. The y-intercept is 0, 6. For part E, we are asked to sketch the function. We're given now vertex 1, 8, x-intercepts negative 1, 0, 3, 0, and we found our y-intercept 0, 6. We can use this information to plot our points and create the graph. So we have our vertex at 1, 8, our x-intercepts negative 1, 0, 3, 0, and our y-intercept at 0, 6. So there's a rough sketch of our graph. We can determine the axis of symmetry, and the axis of symmetry for a parabola that points either upward or downward is a vertical line that perfectly bisects the parabola. In this case, that axis of symmetry is x equals 1. We need to determine our maximum or minimum value of f, and because this is a parabola pointed downward, it has a maximum. The maximum value is 8, and it occurs at x equals 1. So we say our maximum is 8. Next, we'll write our domain and range in interval notation. Since the parabola is angled outward and will eventually encompass the entire x-axis, we would say that the domain is all real numbers, or in interval notation, we say negative infinity to positive infinity. The range is the set of all numbers for which the graph is defined along the y-axis. Our range would be from negative infinity to positive 8, including positive 8. So there's our range from negative infinity to y equals 8. So we've completed our analysis of this quadratic function and created a graph. I hope you enjoyed this video, and we'll see you next time.